Assalamualaikum and hi. We are from RCDCS 1434D. We'll present about our subject, which is Linear Algebra 1. This is our group members: Aisyah Sabrina, Nur Farhaini, Arisa Sufina, Safia Erdina and Ilmuna. First, solve system of linear equation by using different method. Our task is to construct a 5x5 matrix system of linear equations. So, this is our equation. First, solve equation by using Gaussian elimination method. First step is we have to change our equation into a metric form. Second, we have to solve it until it become a triangular matrix. And the third step is solve it until we get the answer. So the final answer is P equal to -5, Q equal to 5, R equal to 5, S equal to -10 and T equal to 8. Second, using Gauss-Jordan elimination method. First, we have to do same as Gaussian method, which is change it into matrix form. Second step, row 1 divide by 2. For row 2 plus row 1 multiply by 3. For row 3 plus row 1 multiply by 4. Next, row 4 minus row 1 multiply by 4. Row 5 plus row 1, and row 2 divide by 13. Next, row 1 minus 5 over 2 multiply by row 2. For row 3 minus row 2 multiply by 12. For row 4 plus row 2 multiply by 3. Next, row 5 minus 25 over 2 multiply by row 2 minus 13 over 233 multiply by row 3. Row 1 plus 35 over 13 multiply by row 3. Next, for row 2 plus 12 over 13 multiply by row 3. Next, row 4 minus 159 over 13 multiply by row 3. For row 5 minus 202 over 13 multiply by row 3. Next, 233 over 1564 multiply by row 4. For row 1 plus 123 over 233 multiply by row 4. Row 2 minus 71 over 233 multiply by row 4. Next, for row 3 minus 174 over 233 multiply by row 4. For row 5 plus 1001 over 233 multiply by row 4. For row 5, 46 over 2649 multiply by row 5. Next, row 1 minus 87 over 46 multiply by row 5. Row 2 plus 177 over 46 multiply by row 5. Row 3 plus 52 over 23 multiply by row 5. So, for the last step, row 4 minus 93 over 46 multiply by row 5. So, we will get our answer. So, this is our final answer. P equal to -5, Q equal to 5, R equal to 5, S equal to -10 and T equal to 8.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farhaini binti Muhammad Azali. So today I will explain about how to solve system of leading equation by using Cramer's rules. So first and foremost, we have to know what is Cramer's rules. So Cramer's rules is an explicit formula for the solution of a system of leading equation with as many equations as unknown, valid whenever the system have a unique solution. It expresses the solution in terms of the determinants of the square coefficient matrix and of matrices obtained from it by replacing one column by the vector of right-hand side of the questions. So another way to solve the Cramer's rules is we can solve that by using formula. So the formula is x1 equals to determinant of a1 over determinant of a. So I will explain more with the next example. Next, for more understanding, I will explain the sample questions and I will answer it for you guys. So the questions is say, use Cramer's rules to solve the system of linear equations given. So step 1, we have to change the system of linear equations into matrices like the picture above. That is how we transfer system of linear equations into matrices. So step 2, we have to replace column 1 with B. So what is B? B is the right vector of our system of linear equations. So B is negative 21, negative 73, negative 1, negative 56 and negative 112. We need to replace B into column number 1. For step 3, we need to use formula to find the answer. So the formula is P equals to determinant A 1 over determinant A. So from the matrix that we create before, we need to find the determinants. So after we find the determinants, we solve that by using formula. So the final answer, you must get P equals to negative 5, Q equals to 5, R equals to 5, S equals to negative 10, and T equals to A. So how about the others? How about Q, R, S, and T? So you need to repeat the same step as I mentioned before. You need to repeat the step 2 until step 3 but using the different column. So next, you need to repeat the step 2 by replacing column 2 with B, and the next, you have to replace column 3 and so on. So that's how we get the answer.
So next, I will present to you inversion method. This theorem solving a system of linear equation using the inverse. If matrix A is invertible, then we can solve the equation AX equal to B by multiplying both sides with A inverse. It will be A inverse multiplied with AX equal to A inverse B, and we will get X equal to A inverse B. This system has a unique solution. Next, we will use the same equation, but this time we will use inversion method. Firstly, as usual, change it to matrix form. Second, find the inverse of matrix A using A augment with identity equal to identity augment with A inverse, and you will get the result of A inverse. Next, this is X equal to A inverse B, and you will get the result P equal to negative 5, Q equal to 5, R equal to 5, S equal to negative 10, and T equal to 8.
Alright everyone, let's talk about homogeneous system of linear equation. A homogeneous system is a system where all the constant terms are 0. For example, 2x plus 3y minus z equal to 0. This system always have at least one solution. It is called the trivial solution. That's where all the variables are 0. In other words, if x equal to 0, y equal to 0, and z equal to 0, if the system have more variables than the equation, it might also have non-trivial solutions. That means some variables are not 0. So remember, homogeneous systems are special because they always have a solution, and sometimes even more than one. Now, let's solve a system of linear equation and determine whether it has a trivial or non-trivial solution. Here's the system we are working with. X plus y plus z equal to 0, 2x plus 3y plus z equal to 0, x plus 2y plus 3z equal to 0. We want to find out if the only solution is a trivial one, where all variables are zero, or if there are other non-zero solutions. To do this, we follow this step. First, write the system as an augmented matrix. Second, apply Gauss-Jordan elimination to simplify the matrix. Third, extract the equation from the resulting matrix. After performing Gauss-Jordan elimination, we get the following matrix as shown in the answer part. This tells us that x equal to 0, y equal to 0, and z equal to 0. Therefore, in this case, the only solution is the trivial solution, where all variables are 0. There are non-trivial solutions for this system. Next, let's analyze another system of linear equation to determine if it has a trivial or non-trivial solution. Here's the system. X plus 2y equal to 0 and 2x plus 4y equal to 0. To solve this, let's follow this step. First, write the system as an augmented matrix. Second, apply Gaussian elimination to simplify the matrix. Last, extract equation from the matrix. From the first row, we have x plus 2y equal to 0. This simplifies to x equal to negative 2y. Let's set y equal to t, where t is any real number. So, x equal to negative 2t. Y equal to t, with t element with real number. Therefore, this system has infinitely many solutions, including
Now I'll be explaining about non-homogeneous case, where the system linear equation must have non-zero value on the right-hand side. Or in other words, I would say that in each equation must be equals to non-zero value. Non-homogeneous case has the form of ax equals to b. To solve this case, we need to change the SLE into row echelon matrix. It may have unique solution, no solution, or infinitely many solutions. Well, there is the example for non-homogeneous case. The question asks us to solve and find a and b value in this SLE. So, first of all, we need to change the SLE into augmented matrix. And then, we need to solve until we get in the form of row echelon matrix. Furthermore, we need to find whether the question is consistent, where it must have a solution. So the first is unique solution, where a equals to 0 and also b is the element of not equal to real number. And then we need to find the infinitely many solution, where a equals to 0 and b also equals to 0. For b question, the question asks us to find the inconsistent, where it has no solutions. We need to make sure a is equals to 0 and also b is not equal to 0.
Next, I will explain about determinants by using formula and cross multiplications. When we need to use the determinants by using formula and cross multiplications, so for determinants by using formula, we can use this if the matrix is 2 times 2. So the formula that can be used is AD minus BC. For determinants by using cross multiplication, we can use this only for if matrix given is 3 times 3. So we use the formula S1 minus S2. So here are the example of determinants by using formula and cross multiplication. So question 1 said evaluate the determinants by using formula given A equals to 7, 6, negative 2 and 3. Since the matrix is 2 by 2, so we have to solve it by using formula. So the solution is determinant A equals to AD minus BC. So equals to 7 times 3 minus 6 times negative 2. So the final answer is 33. Okay, so for the second example is evaluate the determinants by using cross multiplications. Given that the matrix A is 4, 0, 3, negative 3, 1, 2 and 1, 7, 5. So as we see that the matrix is 3 by 3, so we have to use cross multiplications to get the determinants. So the solution is we have to rewrite the first two columns on the right hand side. So and then next we have to use the cross multiplications to get the answer. So determinant A equals to S1 minus S2. So the final answer is negative 102. Next, I will explain about determinants by using cofactor expansion. So before we need to use this cofactor expansion, we have to know about what is minor and cofactor. So let me explain for you guys. Okay, what is minor? Minor is defined as the determinants of the n minus 1 times n minus 1 matrix, which is obtained by eliminating the ith row and jth column. So next, what is cofactor? So cofactor defined as Cij equals to negative 1 I plus j m times mij. So negative 1 I plus j has a value of plus 1 or negative 1. This implies the Cij equals to plus minus mij depending on whether I plus j is odd or even. So here are the example. Find M23 and C23 for the matrix given. So how to solve the M23? So we need to eliminate the second row and the third column. Then we need to use AD minus BC to find the determinants. So the answer is 26. So how we need to solve C23? So we need to use the cofactor formula that was negative 1 to plus 3 M to 3. So the negative 1 is power of 6 times 26. So the answer is minus 26. So here are the example of determinants by using cofactor expansion. So the question is, evaluate the determinants A by using cofactor expansions along the first row of A. So the given matrix A equals to 403, negative 312 and 175. So the solution is determinants A equals to A11 C11 plus A21 C21 plus A31 C31. So what is A11? A11 is the element in the first row and the first column. So that's why we get 4. Next, how to find the C11? C11, we go back to the matrix. Okay, so we have to eliminate the first row and the first column. So that's why we get 1, 2, 7, 5. So next, we can use the same method to find A21 and C21. So as you can see, we get the matrix 2 by 2. So we have to use formula AD minus BC to find the determinants of the questions. So next is 4 times by negative 9 plus negative 1 times 0 plus 3 times negative 22. So the final answer is negative 100.
For the determinants of row reduction, the question given is find determinant A by using row reduction. We will use a series of row operations to simplify this matrix to upper triangular form, keeping track of any changes to the determinant along the way. Step 1. First, we swap row 1 and row 3. Step 2. We update row 2 using the operation R2 equal to 3R1 plus R2. This helps us eliminate the first element in row 2 below the leading one. For row 3, we use R3 equal to negative 4R1 plus R3. This operation is designed to create a 0 in the first column of row 3. Now, we have divided row 1 by 22 as shown by R1 over 22. For step 5, we continue with R3 equal to 28R2 plus R3, which helps us get a 0 in the second column of row 3. For step 6, finally, row 3 is scaled by 11 over 51. After all this row operation, we get determinant A by multiplying negative 1, 22 and 11 over 51. So using row reduction, we have shown that determinant of matrix A is negative 1, 0, 2.
Now I'll be explaining about the application of determinants. In this case, we have two methods, which is adjoint method and also Cramer's rule. The first example is find inverse using adjoint method. In order to solve this matrix, we need to follow the step thoroughly. The first step is find the cofactor of A. Next, find the adjoint of A by transpose the matrix from the cofactor. Thirdly, we need to find the determinant of A. And fourth, we need to use the formula of A inverse, where 1 over determinant of A times adjoint A. After applying and substitute all of the value into the formula, we could find that the answer will be like in this slide. On the other hand, we have to find the inverse using Cramer's rule. Given the SLE in the form of AX equals to B, first of all, we need to change it into augmented matrix. And then, we have to find the determinant, where D equals to determinant of D, where D could be D1, D2 or D3. Dx is the matrix obtained by replacing ith column with B. Firstly, we need to find the first determinant of the original matrix. Secondly, for finding A1, we need to find the determinant of A1 by replacing column B into the first column. And it goes on with other matrices for A2 and A3. So for A2, we need to replace the column B into the second column of the matrix A. And it goes on with A3. After finding out every determinant for each matrix, we could apply the Cramer's rule formula, where the formula is determinant of AN over determinant of original A. Here is the answer for x1, x2 and also x3. Please note that this method only can be used for square matrix, which is non-singular. Secondly, if determinant of A equals to 0, the system does not have unique solution. Thus, Cramer's rule cannot be applied.
Next is singularity. Singularity occurs when the determinant of a matrix is equal to 0. For example, we have the question of matrix 3 by 3, 5, 2x, 0, negative 1, 1, 3x, 0. Firstly, find the determinant n equal to 0. Next, we find the determinant using cofactor expansion along the first row. You will get 5 matrix negative 1, 1, x 0 plus negative 1 multiplied by 2 multiply matrix 0, 1, 3, 0 plus 1 multiplied by x and multiply by 0, negative 1, 3x. And calculate, we will get negative 2x plus 6 equal to 0. And the final answer is x equal to 3. Lastly, this is our conclusion. In this project, we use Mapper software to solve a 5x5 system of linear equations using Gaussian elimination, Gauss-Jordan elimination, Cramer's rule, and the matrix inversion method. Each method highlights different strategies and reveal their strengths and limitations in computational solving. We also explore homogeneous and non-homogeneous systems to understand the differences between trivial and non-trivial solutions and learn how to determine whether a system has a unique, infinite or no solution. Additionally, examining determinants and matrix singularity help us understand how matrix properties affect the solvability of systems. Overall, this project strengthens our understanding of linear algebra and improves our ability to use computational tools effectively.